Hello, everyone. Thanks for attending today. It's great to be here with you, digitally at least. Thanks for attending Digital Velocity. In this session, we'll be talking about machine learning. In particular, we're going to talk about how to drive better customer experiences using machine learning. My name is Dave Lucas. I'm Senior Director of Product here at Tealium. I focus on products related to analytics, machine learning, AI, and other emerging technologies related to data. I've been a contributor and a leader of data teams in various industries for over 15 years. And most recently, before I joined Tealium, I was head of data for an e-commerce brand where I was also a Tealium customer. So a quick agenda for today. I'm going to try to demystify the state of ML at the moment, where the industry is at. I'll give an overview of the process and ideas for how we can improve it and how we can better ingrain ML into our businesses. I'll discuss tools and options out there to accomplish that. And lastly, I'm very excited to share our new machine learning capability, Tealium Predict. So why do we care about ML, right? Why is it remaining such a hot topic now? I think it's kind of like this meme, it's because we think that ML is potentially going to be revolutionary for us. It's going to change everything. It's going to take us to a whole new level. Last August, Gartner put out this graphic. It shows the hype cycle of various technologies. And they said that machine learning was at peak hype cycle, meaning that people tend to have highly inflated expectations compared to the realities. This graphic absolutely still holds in 2020. We hope that machine learning will be that revolutionary gold mine that it'll take us to the next level. But the truth is, when you try to actually ingrain machine learning into your business, you stop calling it magical and you pretty quickly start referring to it as other words. And I'll try not to use any four-letter ones here other than slow, difficult, daunting, expensive, and even words like discriminatory and privileged. While we do see a handful of success stories of businesses who brought revolutionary changes through successful use of ML at scale, these tend to be a small group. They tend to be the tech giants. They often own the very cloud infrastructure systems and platforms that we all use for machine learning, and they can afford to invest huge sums on large, sophisticated teams and infrastructure. So, hence that aspect of privilege that I mentioned. And survey after survey validates this, including the one shown here. Most businesses who are trying machine learning are not really seeing revolutionary gains in their revenue, their profitability, or their other KPIs yet. Getting to that value is taking a little longer than anticipated. Most companies don't consider themselves sophisticated, as we see here. And as an ex-data scientist and head of analytics myself, my hunch is that even some of the companies in this 8% are judging their sophistication only in terms of how technically good some machine learning model that they've created is, right? Like how well they've managed to get that code to work, or how good of a performance score they've managed to get out of a model. My guess is that they're not really answering this sophistication question in terms of how sophisticated their overall process is, or the return that the business is getting on machine learning investments, or on the time to value for machine learning projects. And that's a key distinction because a model itself is nearly meaningless. What matters is the real world value that stems from it, how it benefits your customers, how it benefits your team, the world, your business, what have you. I'm not disparaging any of those brands, any of these survey respondents. Of course, I have no doubt they're doing clever, very difficult things with the technology. But from a process standpoint, I believe there are probably still huge gains to be made. And I know this from past experience, and now that I'm here at Tealium, I hear it from our customers all the time. One primary issue is that a typical machine learning project requires a ton of back and forth between teams. So perhaps an executive or a marketing team or another business team has a need, right? And it's tied to a KPI or a goal. And it turns out that machine learning might be a great tool to help. So the team isn't really able to serve themselves and meet their own needs, obviously, since ML requires highly specialized skills. So they pass the project to their data scientists or their data team, who get to it when they can, right? They've got their own backlog and their own set of priorities. So this data science team has the skills to create the model for you, but then they usually encounter huge challenges around trying to deploy that model to production, meaning to integrate it into your production systems of your business so that it can actually interact with them at scale, right? And in a time frame that works. So now they have to pass the project to the engineering team. So engineering, DevOps do their part. This might take some iterations and release cycles. Then they notify the data team. Now we do more iteration, likely back and forth between data science and development a lot of the time. Eventually, that marketer, that business user, that CEO gets something back. Maybe it's still useful. Sometimes, a lot of times, unfortunately, it's not. It's gone stale by now. This is a very long, expensive workflow. And what if that initial request wasn't even very difficult? What if you have 10 or 50 other requests? It'd be amazing if we could eliminate some of the complexity here and speed up this process. Even if we only focus on the technical portion of the process, it's still very complex. The model is what gets most of the attention, most of the hype, but look at all these other steps that it requires to actually bring that model to fruition and accomplish what we need. This is an exhausting process. And it's already difficult and slow enough under normal circumstances. It becomes borderline impossible during times of disruption. And unfortunately, we're seeing that on an incredibly painful scale in 2020. For many industries, February and March 2020 have looked like this. This shows the daily changes in restaurant reservations in various US states compared to the same day the previous year. So it's going through March, showing year-over-year changes per day. And that wall of dark red beginning in mid-March, unfortunately, denotes a 100% decrease in business, which is just awful, unbelievable. How could you have forecasted that? For an extreme contrast, here's a similar graph of March estimating year-over-year changes in toilet paper purchases. It goes from flat, gray, ho-hum, kind of a boring industry, not a lot changing, to a massive sudden increase. We all know, though, that wall of green isn't sustainable either, right? Regardless of red and green, the point here is that this unforeseen era has thrown all of our forecasts, all of our models, all of our typical means of business planning out the window. Our normal ways of planning are gone. We can't use historical data to make a good model now about the present day. We need to go back to the drawing board, really, and we need to, technical difficulties. We need to go back to the drawing board here, and we need to try creating new models to inform a new strategy. But how are we realistically going to accomplish that when the process is so slow? Ideally, we need a fundamentally simpler process. Now, I'm not naively going to say that we can pivot everything on a dime, of course. Just that it's critical that we look for those opportunities we have to go faster, to use a more agile process, faster process during these uncertain times. So what are the options available right now for ML? If you're looking for a way to move faster with machine learning, or if you're shopping for your first solution or a supplementary solution to what you may already have, it's tough to know what the lay of the land is, what the general categories of solutions are, let alone which one may be best for you. Many tools are still built for experts by experts, right? And we can summarize the market under 4 general approaches. This is kind of how I like to simplify the categories. First of all, we've got exploratory, and this is a category of tools that kind of take a brute force approach, meaning you provide them a data set, and then they just throw everything at it. Try a ton of models, try a ton of different configurations, and just see what sticks, right? So most of it is garbage, so to speak, but some of it might be immensely valuable, and you move forward from there. The do-it-yourself approach is obviously the classic, the original. This is often using open source code libraries, whether it's like a PyTorch or TensorFlow or some of the features available in SageMaker. A data scientist or an engineer is handling everything end to end. It gives you maximum control, but it also takes maximum time, maximum effort, maximum iteration. Now we're seeing a newer wave in the last year or two where some tools, especially in the MarTech area, have started offering this idea of bring your own model functionality. And BYOM, as we kind of call it, usually means that they've taken a Jupyter notebook or another common interface for writing machine learning code, and they've put that in their tool so that now a data scientist can come use that interface to write model code in that marketing tool, and then the model itself runs in the tool. So the benefit here is that the data is available in the tool already once the model runs, right? And lastly, we're seeing auto ML tools that do some or all parts of the process for you. Now, a bring your own model tool kind of is an auto ML tool on one level because they're handling that deployment for you. They're actually running the model for you. So what I mean by this fourth category, I'm going to specifically refer to end-to-end auto ML. And what I mean by that is describing an auto ML tool that essentially handles everything for you, not just that deployment piece. So when we compare the four approaches, one key differentiator is what happens after your model is completed. The two approaches on the left, as we can see here, you now need to pass along the results of your model to another system so that you can take action on them and realize value. Now, this step is something that I like to refer to as activating the value of your model, right? It's akin to how other types of value can just remain dormant until you put them to use. So each approach has its time and place, no doubt about that. However, if you're doing a project that ultimately benefits a customer-facing team, or if it's a really time-sensitive use case, such as cross-channel segmentation for your marketing team, where you want to provide personalized messaging and experiences as quickly as possible, these two approaches on the right are typically going to be faster to achieving that end value. That bring your own model approach, let's talk about that one for one more minute. That's something we evaluated a lot when we were creating our first machine learning product here at Tealium because, it seems intriguing, right? Theoretically, it's allowing you to activate the value quickly since it's already in the tool, but it's also providing a lot of flexibility because you're writing your own code. Unfortunately, in reality, we found through a lot of research that this approach has some pretty serious drawbacks at times. For example, the main one, it still requires a highly skilled user. It still requires that rare data scientist or machine learning engineer to come in and create everything, babysit everything. Still a ton of work, right? It's still a ton of effort, a ton of that person's time, and ongoing maintenance as well. And then we still got technical concerns around how well the model you're writing is working with the input data set available in the tool, how well their deployment infrastructure is working. What if they don't have that great of a deployment setup and you don't really have any ability to control that? And what if the model you wrote is going too slow, right? There's various types of performance concerns going on here. This is a big point as well. How many types of machine learning models do you actually want to bring into a marketing tool at the end of the day? How many tools are you actually going to message based on that, right? If we think about it, or if I refer to the research and the conversations I've had with many of our own clients, everyone pretty much wants to do the same thing. Even the largest, most sophisticated brands are looking for a simpler, faster, easier way to predict what their users are going to do next. That's what everyone wants. And that, no matter what user behavior you're predicting, whether it's likelihood to purchase or to register or just to return to an app, that's really one type of model, and it's just different flavors of that one type. There aren't really very many other model types you'd actually want to bring into a tool like this. So in the end, we see that overall, the BYOM approach is still a somewhat slow time to value in some cases. Maybe now you don't need to involve engineering and development on that diagram I showed earlier, passing the process between teams. Maybe now we don't need engineering, but we still need the data science team, and there's still a lot of back and forth between teams. If we want to fully eliminate that back and forth, and we want to allow a business user to handle their own needs, especially in any kind of quick, time frame, we need an end-to-end auto ML solution that's going to completely eliminate whole chunks of this process. Now, this is the only approach that's actually going to let the business users serve themselves. This is kind of how ML becomes mainstream, if you will. We kind of joke. It doesn't take any code, it doesn't take any special knowledge. Anyone can use it. For the first time, we're saying that anyone could use a tool like this. You don't need to be an expert. And it's minimal risk, minimal hassle, because many chunks of the process are just done completely for you. Second set of benefits here, the end-to-end tools, is that we don't need to focus on technology. We can just focus on the customer, on the business goal, right? And guaranteed performance, right? If the tool works well, the tool works well. Everything's built in end to end. There's no strange variables potentially being introduced with bring your own model code that may or may not interact well with the rest of the system. You don't have to worry about latency across systems like you might if you did it yourself outside and now brought it into a marketing tool. And it's just reduced risk, right? There's less security risk, less risk of privacy and consent settings, and choices carrying over between tools, etc. It's great that we're seeing these kinds of end-to-end tools appearing on the market, right? We've seen them starting to appear within some marketing tools, as I mentioned. These tend to be point solutions, maybe a messaging tool, maybe an advertising tool. And even now we're seeing them within other types of customer data platforms and related foundational tools like that. The problem I'm seeing, which really concerns me, is that a lot of these solutions have veered too far towards simplicity. They're sometimes just baking in rigid algorithms, hard-coded formulas, instead of giving the real power and flexibility of true ML. For example, let's say a tool predicts each of your visitors' likelihood to purchase, right? Well, what if that's just a one-time prediction? And what if it's based on a hard-coded formula that doesn't have anything to do with your real-world business logic or your particular situation? And if this prediction is valid for all of eternity, does that mean it's valid at all, right? How can they nail that so perfectly? Frankly, especially in a time like this, like we're going through now in 2020, there's no way a prediction like that can still be valid right now. We need a lot more flexibility and a lot more, control over the time frames, the parameters of the models, etc. So we need to find the right balance is what it comes down to. We need to know when to emphasize simplicity and speed. When do we seek to maximize control and flexibility? And that's a tough balance. It depends on your use case even. And, I haven't seen that balance struck anywhere quite right on the market yet with AutoML tools. And that's why we've built Tealium Predict. Predict is an end-to-end AutoML tool that sits atop our AudienceStream Customer Data Platform. It handles the entire technical process for you from dataset preparation all the way through model training, deployment, maintenance, etc. With Predict, any non-technical user can create, train, and deploy a machine learning model without writing a single line of code or needing a degree in statistics. It takes about 1 minute, takes about 5 clicks. You simply choose any user behavior you want to predict, and you choose the time frame you want to predict it for. We've even removed the need for guesswork and exploratory analyses here by showing you which user behaviors are ready for prediction and which ones may need a little additional data or time. So for example, let's say we have a behavior which occurs fairly sporadically on our website and there's not a lot of data about that. We'll list this one here as unhealthy for ML right now and give you tips on how to improve that for the future to get it to a healthy state where it's ready to run predictions on. There's no need for you to do any prep work with your data set, no need to do any data wrangling, integration, anything like that. If you want greater control over your model, if you want to tweak it, we offer advanced configuration options. You can exclude attributes, you can change the date range for training your model, etc. The name of the game here is flexibility and transparency, avoiding black boxes, avoiding rigidity. Once you complete those simple steps, your model is automatically trained for you. If you'd like to dig into the details, once it trains, Predict provides you all the metrics that a data scientist would expect to see for a model of this type. So we'll show you the details of the sample, an F1 score, a confusion matrix, the ROC curve and the area under the curve, distributions, etc. We also show you the exact data attributes, so the exact data points within your overall data set about your visitors, which compose these algorithms so that you have full transparency. We find that customers really enjoy this because they can now see the predictive factors in their data set that they may not have known about before. If you want to train a new version of the model, it's just a few clicks. And if you like what you see, you can deploy this model live in 1 click. So now that you're visiting the Model Explorer here, you can see every version of every model you've created. You can see details about their trainings, the health scores, as well as trend reports for the predictions being made by any models that you've deployed live. So a deployed model is going to run after every visit, every session by every visitor. These predictions are immediately integrated into your AudienceStream data set, and they're available real time for activating however you like. So you can create smarter audiences, you can orchestrate personalized experiences across all your channels and tools. You can use the predictions for your business intelligence program, for your own data science projects as engineered features, etc. Effectively, what this allows you to do is empower your entire downstream MarTech stack with consistent machine learning powered data, regardless of whether all those tools in your MarTech stack have any machine learning functionality on their own. Now with Predict, we're avoiding the typical problems of do-it-yourself solutions, right? Where you've got to deal with isolated data sets, there's an enormous amount of prep work, there's a lot of maintenance involved once it's deployed, and overall slow time to value. And it avoids the pitfalls of those end-to-end AutoML tools, such as overly simple, rigid black box style formulas. So here's a quick example use case. Let's walk through a real world example. So let's say I have a retail business. We have our e-commerce website, we have our point of sale system, and we've got a mobile app. With Tealium Audience Stream, all the data being generated by these three sources in real time can be integrated, collected, cleaned up into a nice set of correlated visitor profiles, so you know everything about each of your visitors, cross-session, cross-device, etc. Now with Predict layered on top of Audience Stream, we can run machine learning models to predict any visitor behaviors you want. So anything occurring on any of those sources, any behaviors you track, anything else you bring in off of offline data, we can predict that. Here we might want to predict likelihood to purchase in the next 2 days. So let's say our goal behind that is we want to improve the efficiency of our cart recovery program. Or maybe we've got a sale going on and it ends in 2 days and we want to get a feel for who's likely to convert there out of the people visiting today. So now this model is going to run right on every session by every visitor. So we've got individualized predictions. If one visitor visits multiple times, it keeps generating new predictions so it remains fresh. These predictions are instantly integrated back into the visitor profiles, into your data set, so that it's easy to use them on their own or to combine them with any other data attributes in that data set to create nuanced, intelligent audiences, which, like I said, can be connected downstream to any tool or channel you like. In the example here, let's say I want to make 2 audiences, right? I want to take one group of, I'll use my predictions and I'll say, give me everyone who's less than 20% likely to buy. Let's just suppress them from all advertising, right? To improve our efficiency and our marketing end. And then let's take a second audience of the people who are highly likely to buy. And let's use an audience there to coordinate site personalizations and cross-channel, cross-tool messaging. So your imagination here is the limit on what behavior you predict, what audience you create, and how you take action on it. To be honest with you, every time I show this slide, I kind of tell a different story because you can just talk about a different real-world business goal and adapt it to that. Predict is incredibly malleable like that. So in sum, we believe that this is what a great end-to-end machine learning tool looks like. It solves the real-world problems that I experienced firsthand, and it's solving real-world problems that our early users are experiencing. These are all sophisticated enterprise brands, often with their own experts and their own data science teams, and they agree that this approach is incredible for facilitating marketing use cases, for getting time to value quicker and quicker for those business users, and actually for complementing the work that data science teams might be doing themselves, right? We can free those teams from doing some of the common use cases and dealing with activation work, and we can let them do that really nuanced expert work that's unique to your business. So with Predict, the goal is to offer you ML functionality to let you better know your customers and shape better experiences for them. And then the second goal is to give you back time and control over the process. We've reduced some parts of that process from 60 days, 90 days, a year, down to just a few minutes. And then for other parts of the process, we've reduced it to 0 minutes. We completely do it for you. If you're an AudienceStream customer and you'd like a demo to see what Predict can do for you, please reach out to your account manager. And for everyone else, please check out the link here, tealium.com/predict. I'm incredibly excited to hear how you use Predict, to hear your feedback about it. And thanks for your time today. Thanks for attending Digital Velocity.